Right, so hello students, this is lesson 3 of the sine rule. This lesson is focused on problem solving, so using the sine rule to find angles or to find sides, but in situations which may not immediately present themselves to be, straightforward sine rule questions. So part of what we've learned so far this week is about asking yourself, when you see a question, is it a right angle triangle? That's one important question to ask yourself. And question 2, do you have a matching angle and side? Now, that's all well and good when there's a nice triangle drawn for you, but it's a very different situation when, it's not immediately presenting the problem, when you're just given some words that say, I don't know, there's a balloon flying in the sky, or there's a satellite above the Earth, and it makes an angle of 62 degrees with the ground. How high is it in the sky? Questions like this require you to really think, and in most cases to draw a diagram yourself. Okay, so let's get into it and try and figure out the problem. So this is one of the features of the question. So this one has drawn a diagram for you, and one of the things that I'd really want you to focus on here is you need to be able to spot the triangles. So I'll read the question to you. In the diagram, points D and E have lines of sight to the top of a monument at M, which make angles of 29 degrees and 57 degrees respectively. In other words, D looking up to M, that's an angle of 29. E looking up to M, that's an angle of 57. The length of DE is 56. Now that's one thing they haven't put on the diagram. Now that's a common feature of exam questions. So my first hint really is if there is a diagram and they've missed some information, you can put that in yourself. So D to E, that distance there to there, is 56 meters. Okay, calculate the height of the monument to the nearest tenth of a meter. So with this question, guys, what we need to think about is, or the point really of this is that you can spot different triangles. So straight away, some of you will have seen that triangle, hopefully. Okay, now in that triangle, on the face of things right now, I only know 29 degrees. That's all I know. But here is something else to remind yourselves. If I, in a purple pen, remind you that's a straight line, and you know that this angle here is 57. If you know that, then you can work out this angle, because angles on a straight line add up to 180. So straight away, using a very basic bit of maths, that's like year 7 you were taught that, angles on a straight line, you've worked out one of the angles inside this triangle. And from that, if you work out this angle therefore has to be 123, for example, I can then say, well, the angle at the top, because angles in a triangle add up to 180, so the angle at the top has to be, I'm going to calculate for this, 1, 2, 3 plus 29, so that angle has to be 28. So I've now, from a position where I didn't know much about these triangles, I know all the angles inside this first triangle, and I've added that bit of information on from the question, 56 meters. Okay, so spotting the triangle, spotting what you can work out is one of the real tricks of this sort of thing. Okay. Now aside from that triangle, there's another triangle which many of you hopefully will have spotted, which is this triangle. Now it talks about the monument M. Now that triangle is a right angle triangle. I can see that because there's a monument which goes directly up, directly vertical. So directly vertical from a horizontal ground, imagine I'm standing here and directly vertical, that is always going to be a 90-degree angle there, right? So you need to be able to spot the different triangles. And there is, for a bonus point, a positive if we were in the classroom, is there another triangle in this diagram? Of course there is. Look, one more, the bigger triangle, and that one is also a right angle triangle. There's the right angle just there. Okay, so you need to be able to spot the different triangles. in various questions. We'll look now at one more. We'll look now at how to sketch a problem. Okay, so first step for sketching is reading carefully. So I'm going to read this question. You guys read it to yourselves. I'm going to read it out now. A bird is flying above the ground. It sees a frog sitting on the floor in front of it. Behind it, also sitting on the floor, or standing I should say on the floor, is a deer. The angle between the frog and the bird is 45 degrees. The angle between the deer and the bird is 27 degrees. The distance between the deer and the frog is 200 meters. Assuming that the floor is perfectly flat, work out how far above the ground the bird is flying. Let's have a go at drawing. A bird is flying above the ground. So if I just put a B here for bird, and there's my ground, and it sees a frog in front of it. So I mean, I'm going to pretend that the bird is sort of looking that way. Okay, so here's my terribly drawn bird. Please don't laugh, or if you do laugh, I won't even know if you are. So there's my awfully drawn bird. Yep, that's my bird there with, I don't know, like a tail. Okay, so there's my bird, and it's looking at a frog, which is sitting on the ground. And I'm going to put an F here for frog. Okay? And behind the bird, I'll just draw another little dotted line over here, is a deer. And I'm going to say D for deer. Can you see the triangle? I certainly can now. Suddenly seems so much more understandable. We can start adding some numbers in as well. The angle between the frog and the bird is 45 degrees. Angle between the frog and the bird, 45 degrees. Angle between the deer and the bird, 27 degrees. The distance between the deer and the frog, 200 meters. So now, if I kind of forget the terrible bird drawing for a minute, I've now got, I hope you can all see, a triangle. I know two angles, I know a side, and because I know these two angles, 27 add 45 is 72, 180 take away 72 is 108. So I also know that that is 108. The question wants me to work out how far above the ground, so basically how tall, what's the height of this bird's flight. Now to work this out, guys, we need to work out one of the sides, and it is up to you which side you work out. What I'm not going to do, just to be clear here, is I'm not going to do the entire question. I'm going to leave it there as a problem for you guys to think about. But what I'll say to you is, you have got a matching pair, angle side, and you know two angles. So you could, if you wanted to, use the sine rule to work out this side, if I call it, I don't know, x. Or you could use the sine rule to work out this side. I'll call it y. The reason we need to know those is because if I just sort of rub this out, if I draw a line here, I've now got a right angle triangle there. I know this angle, I can work out this side, and therefore, if I just, I don't know, give this another letter, A, I can work out A. Okay? Because if I label my triangle, this is opposite, hypotenuse, adjacent. You remember this, I hope. Once you've got the hypotenuse, which you can do using your sine rule, you can then treat this like a right angle triangle to work out the height. Question says, to calculate the height of a church tower, a surveyor measures the angle of elevation from 2 points, 50 meters apart. So B and A are my 2 points. Calculate the distance B to C. Now, to work this out, to calculate the distance B to C, what you need to do is use the sine rule on this triangle ABC. If I just draw triangle ABC for you, just triangle ABC, it looks a bit like this, okay? So this is C, this is B, this is A. You know that this bit here is 40 degrees. You know that this is 50 meters. And because this bit here is 47, you know that this angle, this one here, has to be 180, take away 47, which is 133. So I've now got two angles at the base and the length or the distance here at the base. And once again, I suppose, once you've worked out that that's 133, you can work out this angle, because angles in a triangle add up to 180. So 133 plus 40 is 173, which means that this is only 7 degrees. Tiny, tiny angle at the top, 7 degrees. Right. Now, we're being asked to work out BC. So this is the length they want me to work out. First question, is it a right angle triangle? Yes or no? No, it's not. Second question, do you have a matching angle and side? Answer, yes I do. There's that side and matching angle. So I can use the sine rule. Am I finding sides or am I finding angles in this question? I'm finding side x. So I'm going to write, if I label it, this will be little a, this will be little b, this will be little c. The matching one is the one that I'm going to write first. So 50 divided by sine 7 is equal to x, that one that I don't know, divided by sine 50. What do I need to do to both sides to get x on its own? Times by sine 50 times by sine 50. That will give me x equals 50 divided by sine 7 times sine 50. Put that in your calculator. And that gives you 314.2892, etc. We'll round it to three significant figures. 314 meters is the answer to the question. So that's part A. Okay? And part B, so if I just sort of put A there, that's part A. Now once you've done part A, look at part B. It says, hence, calculate the height of the tower. So they want you to now work out this. So I'm going to draw that triangle, which is BCD, this triangle here. So this triangle is a right angle triangle, BCD. You've just worked out how long BC is, which was 314.28 blah 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 blah. Leave it on your calculator for now. And you know one angle. So I'm going to ask myself those standards questions again. Question 1, is it a right angle triangle? Answer, yes it is. So I don't even need to ask question 2, which was, do you have a matching side angle? Because you don't need one. When you're using trigonometry, the basics, you label your triangle. Okay, so the final activity then for this lesson is for you to have a go at these two questions. The first one describes a balloon being tethered to the ground by two lines. So it's similar to the bird example from earlier on in the video. Second question is about a TV signal from a transmitter T, satellite, and V. The question's ultimately asking you to work out the height of the satellite above the ground. Okay, so they want you to know that height. So it's similar actually to the question we just looked at. If I just draw a vertical line here, that would create one right angled triangle there, and another one on the other side. So what you need to do is very similar to the last question, the one that I just did, and work out one of the sides. It's up to you which one you work out, either X or Y, and then when you've got one of those sides, then you use the right angled triangle, either triangle number 1 or triangle number 2, and use SOHCAHTOA to work out the height. Okay? Have a go at those two questions, and take a picture of your answer, upload it to complete this lesson's remote learning. Good luck.